I made some changes to that program to illustrate classes in Python. Let's have a look at it. I think you'll like it. Whoa! Check that out! All of these small white boxes are attracted to the beige box. By pressing the R key, I can reset them to a grid-like pattern, and then we can see that the force of gravity pulls them inward. If I move the box, of course, they get attracted to a different location. Wow. Look at that. Let's start from outside and sort of tease this fabric into a different shape. I love to see it break and curl in on itself. If you're careful, you might be able to get these little guys to orbit your box. They tend to get thrown away at high speed. To me, this is so much fun to watch. I hope it comes out well on the video. Okay, well, without getting too mesmerized, let's close this and look at the source code. Here it is, example3b.py, and you note that at the beginning I write from support import star. That's because I've split the code into two documents, the document you see here, which is almost the same as it was before, and this support document which defines this game object class. More on that later. Let's look at the main file for a moment here. The setup is the same as before, and then I define a game objects list. Instead of storing all of the velocities as one list, and all of the coordinates as another list, and all of the colors as another list, and so on, instead I store all of those attributes together with the entity to which they belong. So that means that each one of those things you saw on the screen was just a game object, which is something that I invented for this. I just made it up. So the player is one. He's got some information associated with him, and this is the constructor for the game object. If we look over here, we see which pieces of information are needed. The game object contains, ignore this piece, coordinates, velocity, something that it orbits, a size, and a color. The player has these coordinates. It starts out with no velocity. It doesn't orbit anything, so I have an empty set of brackets here. Its size is 50 by 50 pixels, and its color is beige. I append the player to the game objects list. Okay, now I add in 50 by 50 array of satellites. Their coordinates are given by these numbers I and j. Their velocities start out at 0, though you could experiment and see what happens if that doesn't start at 0. Okay, now we make a bunch of these satellite objects and we give them the player coordinates to follow as their orbital center. And you may think, oh, but then they'll only follow the coordinates at the time they were created. Aha, but the way lists work in Python, a list, when it's passed like this as an argument, is actually passing a reference to wherever that list is stored in memory. So that means that when the player coordinates change, the satellite will know those changed values. So that means that this works well, and I don't have to continually update the satellites with what the player coordinates currently are. In a sense, you could say this is an advantage of using this type of format where we're using lists and objects instead of primitives defined like my x equals 5, my y equals 10. If I put a list here, my x, my y, because those are primitives, they would be sent as actual numbers instead of a reference to the value. So pluses and minuses there. Okay, so then I just append all those satellites one by one to this game objects list. That makes the game loop super simple. Okay, we check if the window was closed. That's the same as before. I've added an event for in case the user has pressed the R key. So event.key equals pygame.k_r. And if that's the case, then for each object, for G in game objects, g.reset. And g.reset is really simple. If you press the reset button, it calls the reset method. And if you've used reset, it checks if the length of the orbits is 0, because I only want to reset the location of the satellites, and satellites have a non-zero orbital center. That is to say, they have coordinates for what they're orbiting. So I can set the coordinates x to the starting coordinates, and same thing with y. And I do this x and y separately, because if I set the coordinates equal to the starting coordinates, then it would do a change of what that list is. It would now make both lists point to the same place in memory, and that's not what I'm looking for. I'm looking to copy the x and the y numbers over. We'll talk more about copying arrays later. Then I set the velocity to 0, just to reset everything. Okay, so now what happens when we update? This might look a little confusing. I'm updating and drawing in one step. So I draw a black rectangle everywhere to fill the screen with black to reset it. And then for each of the game objects, I just type pygame.draw.rect, and I give it the screen, the color associated with that object G, and then the method g.update returns a pygame.rect. See here, this update method? It returns pygame.rect. It turns into a pygame.rect object that just plops right in here. So this one line both updates and draws the object in question. And how does it update it? Well, the update is a little different if it's the player-controlled object or the orbiting object. And again, I determine whether it's player-controlled by checking if it has something written into self.orbits. So this looks the same as before. And this looks a little different because I've added a little bit of math to calculate something like gravitational attraction. All right, so there you have it, a pretty neat example. I hope you liked it.